Hi guys! As promised, I'm going to start teaching you some science lessons. So get out your science book, in case you forgot in a couple of days. This is what it looks like. We are going to continue with Chapter 9, Lesson 3, and we're going to read pages 408 and 409 together. Just like we do in the classroom, if I stop, I want you to say the next word, okay? Up here at the top of 408, where it says light from electricity. Televisions, computers, and light bulbs all use. These objects are resistors that use the energy in a circuit. Most resistors transform electrical energy to heat and light. The filament in an incandescent light bulb is a resistor. A filament is a thin, coiled wire that can get very hot without melting. Most of the electricity passing through the filament is changed into heat. But the filament is a strong resistor. The filament becomes so hot that it glows, also giving off light. So I went around the house, and my husband likes mostly these light bulbs, but I did find one that is an incandescent. That's this one here. And I know you can't see it, but maybe if you ask your mom and dad, they can help you find one at home. The filament for this incandescent bulb is right here. And I picked this one because if you see right here, this black spot, this one's blown. So this one doesn't work anymore. And what happened is it got really, really hot. And then I'm sure you've seen it before where it makes that pop and then your light bulb doesn't work anymore. So you can see kind of right here where it got really hot. Okay. Now we're going to move to page 409, heat from electricity. When electrical current passes through a resistor, it gives off heat. You ever touch the top of a light bulb? Don't do that, it's hot. This change is why electrical wires sometimes become hot. Some types of wires are good resistors. Many appliances have coils of these wires. More coils allow an appliance to become hotter. The resistor of some appliances gets so hot that they produce a red glow. This glow happens in toasters. All right, so now we're going to answer the questions on page 408 in the math box. We're going to do 1, 2, and 3. So using percents. Electrical energy is measured in units called kilowatts per hour. About 10% of the energy in an incandescent light bulb is used for light. The rest is used for heat. About 75% of the energy of a fluorescent light bulb is given off as heat. So question number 1. If an incandescent light bulb consumes 1,000 kilowatts per hour, how much energy is used for light? And an incandescent light bulb, we're going to remember, is this one. Okay? So let's look back up at our information. And it says about 10% of the energy in an incandescent light bulb is used for light. So we want to take 1,000 kilowatts per hour and multiply it by 10%. And in case you can't remember how to multiply percents or you haven't learned it yet, that's okay. I've done the math for you. And the answer is 100. Question number 2. A fluorescent light bulb consumes 1,000 kilowatts per hour. How much energy is used for light? And this is a fluorescent light bulb, just so you know what it looks like. And let's look back up at our information. And it says about 75% of the energy of a fluorescent bulb is given off as light. So we're going to do something very similar to what we did in question 1. So for question 2, you're going to take 1,000 times 75%. And the answer for that is 750. So which bulb is more energy efficient at producing light? My incandescent or my fluorescent? My fluorescent, which is why my husband has these all over the house, because these are more energy efficient. Okay. All right, guys, good job. I want you to take a look at question number 3 on page 408 and question number 4 on page 409. And then when you're ready, watch the next video and we'll discuss those together. Thank you. Bye.